Good morning to everyone present here. I am Kishoran of DC 3rd year department, here to give a presentation on my report Aircraft Autopilot Pitch Control System, which is the skill assessment of controls engineering subject. Let's move on. First, what is pitch control? It is the nose up and nose down movement in an airplane. That is, the elevation and descent of the airplane is determined by the pitch control angle, which is given by the pilot. Sometimes it may be automatic due to the automatic aircraft control, where the desired pitch angle is given by the pilot itself beginning, because during a long distances, pilot may not manually fly the plane due to tiredness. Hence, in automatic system, the pitch control is used to maintain the stability and the safety of the passengers using the pitch control automatic system. Let's see how it is important and how it can be controlled using the control system. The objective. The first desired pitch angle is given by the pilot. It needs to be maintained throughout the flight. Hence, we need to keep a steady state error. That is, the output pitch angle which is currently going and the reference pitch angle, the difference must be zero. There must not be any deviation to maintain a stable flight. And also, when we fly the plane, we have disturbances like the wind. It needs to maintain the pitch angle despite the disturbances it gives and correct itself to the proper angle set before. The components required for such system are pitch reference, that is the reference angle that is given before, and the gyroscope. It is a sensor which senses the current angle of the pitch. Next, the PID controller, which gives the operation on how much adjustment should be made for the angle to return to its normal position. The wind disturbances, the disturbances that is carried on when the airplane flies, an actuator. This is the elevator which controls the angle after the PID controller gives its input to it. Finally, the aircraft dynamics. How will the aircraft maintain its balance in the flight? This is the block diagram. As explained before, the PID controller, the elevator and the gyroscope, and the feedback is given back to the PID controller, in which the elevation angle is rectified. Next is system operation. First, the gyroscope detects the current pitch angle and measures whether it is similar to the given pitch angle given before, and error is calculated. Then this feedback to the PID controller, which tells how much angle should be adjusted. It is then given back to the actuator, that is the elevator which controls the pitch angle. Then the desired pitch angle is derived by us. The disturbance model, that is the disturbance of the wind disturbances that is occurred during the aircraft control and all. The Simulink implementation. In MATLAB, we are given a Simulink implementation using the reference pitch block and the transfer functions of the PID controller, and the wind disturbance model is given, and finally the feedback is given back to the PID controller and the output is sensed using the sensor scope. This is the result we have achieved. First, when we implement a wind disturbance is given, 45% overshoot above the required angle is seen below. Then, after the second of 7 seconds, the pitch angle is then put to its correct operation. It takes 7 seconds for it to reach desired angle back from the disturbances. Then the steady state error is zero. That's how it is implemented. The operations. Now, this pitch angle control system is used in commercial airplanes for safety, stability and purposes. In military operations, however, we need precise maneuvers and all for operations. That is also using the advanced pitch control system, and also drones for autonomous flight, delivery, etc. Thus, the desired result is achieved in the control system in the pitch control. Thank you.